Hi, this is Mrs. Huntley. This is Module 2, Lesson 12, Angles Associated with Parallel Lines. For this lesson, you're going to need three colors, either colored pencils or highlighters. You're also going to need possibly some tracing paper or your transparency. Your essential question for this lesson is, what are the special angle relationships formed when lines intersect? So the first example that we're going to look at, this exploratory challenge, it says in the figure below, line 1 is not parallel to line 2 and M is a transversal. Use a protractor to measure angles 1 through 8, which, if any, are equal. Explain why. Use your transparency if needed. So what they're telling us is these two lines, not equal. This line cutting through them, the academic language for that, for a line cutting through other lines, is a transversal. They're transversing those lines. So I don't want you to get confused by the language, and we're going to be talking about lines cut by a transversal quite a lot. So let's take a look at this first example here. And I'm going to show you on the overhead how to measure them using a protractor. So just bear with me for a second. And let me switch over to the overhead. Okay, so here we have the overhead, and we'll use a protractor. And remember, I told you about that little bubble being on the protractor, and that's what we put on the angle. And we line up our horizontal line with one of the lines, and that comes out to the 0 here. And then if I were extending this other line all the way up, it's going to be crossing at about 100, and there's 110, 115, 116 degrees. So this one is 116 degrees. Now I'm going to check this next one here, angle 2. I would expect this straight edge to be 180 degrees, right? Because a straight line is 180 degrees. So if I'm using math, and I know that angle 1 is 116, I would expect angle 2 to be 64 degrees. So let's just take a look and see if that's what it's going to work out to be. I really hope it is. Okay, so again, that bubble is right on the intersection. That goes out to the 0. And line this up. Here's 65, there's 64, so that worked out pretty perfect. 64 degrees. Now I'm going to check angle 3. Now angle 1 and angle 3 are opposite each other. There's actually a special angle relationship for angles that are opposite each other. They're called vertical angles. So let's quickly check angle 3 and see. Actually, I'm going to go this way. Can you? Okay, let me push up. There we go. Let's go this way. Sorry, guys. So there's the 0, and it's coming out, and that is, here's 110, or 110, 115, 116 degrees. And then, of course, this one, here again, we've got our straight angle. They're opposite each other. I'm going to expect this one to be 64 degrees, and I'm not even going to measure it. I'm going to say that I know that if angles are opposite each other, they're called vertical angles, and they're going to be congruent. Now, the other way we could have checked this is by using our transparency or our tracing paper. If I copy these angles and I rotate them 180 degrees, which means I'm going all the way around until my lines map to my lines. Here, this is 1, 2, 3, and 4. So I'm going all the way around. Angle 1 and angle 3 occupy the same space. Angle 2 and angle 4 occupy the same space because it was 4 underneath. Here, let me show you. So if I lift this up, angle 1 and angle 3 are in the same location. Angle 4 and angle 2 are in the same location. Same thing up top. And I remember from my rigid motions that angle measures are preserved. So even though I've done a 180 degree rotation, I know my angle measurements are going to be the same. So let's go back to our notes. What notes do we want to take here? Okay, here are the notes I'd like you to take. Angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. Vertical angles have the same measure, and I can prove it by doing a 180-degree rotation. So we were just talking about these angles up here. And what I can do, what I'm going to do right now, is I'm going to use a highlighter, and I'm just going to highlight my angles that are congruent. So 1 and 3 in one color, 2 and 4 in another color. Okay? What I'd like you to do right now is the next set of angles that we have down here, 5, 6, 7, and 8, identify the vertical angles and identify the ones that are going to be congruent. So go ahead and pause the video right now and see if you can do that for me. Okay, so angle 5 and 7 are going to be vertical angles, and angle 8 and 6 are your vertical angles. Now you can do a shorthand like I just did with a little angle symbol and the number, and then my weird little and sign in between. Again, make sure that your notes are legible to yourself. Okay, on the next page, we've got parallel lines. So it's saying line 1 is parallel to line 2, and M is a transversal. So this is your transversal. Transversal, again, academic word for a line cutting two other lines. Use a protractor to measure angles 1 through 8 and list all that are equal in measure. Now I just told you that opposite angles are going to be equal in measure. So I know that 1 and 3 are my vertical angles. 2 and 4 are my vertical angles. 5 and 7 are vertical angles, and 6 and 8 are vertical angles. So I'm going to have 4 sets of different vertical angles that are congruent. I don't need to measure them using a protractor. I know this because of the angle relationships. Furthermore, I'm going to tell you about some other angle facts about parallel lines cut by a transversal. First of all, if we are inside, like if you're inside your house or inside these parallel lines, it's called interior. So inside, interior. Outside, the outside of a house, is called the exterior. So if you are inside these parallel lines, you're going to be inside or interior. Outside the parallel lines, which is out here, those are going to be exterior. So let's just talk this through. I'm going to actually put on the overhead real quick. I'm going to show you something. Okay, so if I copy angle 1, 2, 3, and 4, one, 2, 3, and 4, and then I translate down my transversal to the other set of angle measures. 1 and 5 occupy the same space. 2 and 6 occupy the same space. 7 and 3 occupy the same space. And 4 and 8 occupy the same space. Those are called corresponding angles. If they occupy the same space after I translate them down, they are corresponding angles. And we know that a translation preserves angle measures. So I know angle 1 and angle 5 are going to have the same measure. I know angle 2 and angle 6 are going to have the same measure. I know angle 3 and angle 7 are going to have the same measure. I know angle 4 and angle 8 are going to have the same measure. Furthermore, I translated down. If I translate down and then rotate around, keeping the point of intersection the same until everything matches up, I see that 4 and 6 are going to have the same measure. 3 and 5 are going to have the same measure. 2 and 8 are going to have the same measure. And 1 and 7 are going to have the same measure. If you're like, wait, what? I'm totally not getting this. Don't worry. We'll talk about it more in class tomorrow. I just want you to see that through our rigid motions, we can prove the angle measurements that we're going to be learning about, okay? So let's go back to the overhead, or to the pages here. The sets of angle relationships that I want you to understand is, if we have angle, I said angle 4 and angle 6 were going to be the same, right? Those are inside the parallel lines, and angle 4 and angle 6 are on opposite sides of the transversal. So I would say angle 4 and angle 6 are alternate because they're on opposite sides of the transversal, interior because they're inside the parallel lines, alternate interior angles, and because they are alternate interior angles, they're going to have the same measure. Do you see another set of alternate interior angles in this same drawing? See if you can pick it out. Yep. Angle 3 and angle 5 are alternate interior angles, and they are going to have the same measure. Now, alternate exterior angles also have the same measure. Exterior is going to mean that they are on the outside of the parallel lines. And again, outside actually, I should have said inside over here. Okay, so alternate exterior angles, I've got 1 and 7, and another set would be 2 and 8. Now, corresponding angles are, if I translate 1, 2, 3, and 4, they're in exactly the same spot. I want to know which ones are going to occupy the same space and which ones are going to be congruent. So let's go ahead with a highlighter there. So 1 and 5 are going to be in the same space. 2 and 6 are going to be in the same space. 4 and 8. And then 3 and 7. Okay, so we have a lot of angle relationships that are going to be congruent, and we can prove it using our rigid motions. So let's go through the questions here. What do you notice about angle 1 and angle 5? Angle 1 and angle 5, they share the same space. They have the same measure. If I translate line 1 down M onto line 2, angle 1 and angle 5 will occupy the same space. They are called corresponding angles. 3 and 7, same thing. Those are corresponding angles. What other sets of corresponding angles do we see? Okay, so 3, that's not what I wanted to do. Go back to a regular pen. So angle 3 and angle 7 are corresponding. What other angles are corresponding? Angle 2 and angle 6, angle 4, and angle 8. So there are 4 sets of corresponding angles when 2 parallel lines are cut by a transversal. Okay, 4 and 6, again, opposite sides of the transversal, inside the parallel lines. So if I translate line 1 onto line 2 and rotate 180 degrees, then 4 and 6 are going to occupy the same space. Since they map on top of each other, I know they have the same measure. Since they are on opposite sides of the transversal and inside the parallel lines, they are called alternate interior angles. And alternate interior angles are always congruent. Okay. If you know that pairs of corresponding angles, alternate interior angles, alternate exterior angles are congruent, what do you think is true about the lines? So if I'm given all of that information, if those angle measurements are all the same, so they're congruent, then the lines that are cut by the transversal are parallel lines. Okay? So this is going to bring us to a geometric theorem. And the theorem states, a theorem again is just a rule, a geometric rule that we know to be true. When parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. The converse of the theorem, meaning how do you say it in the opposite way? If you know that corresponding angles are congruent and alternate angles are congruent, alternate interior are congruent, alternate exterior are congruent, then the lines that are cut by the transversal are parallel. That brings us to the end of the lesson. I do want you to attempt to write the summary, and I'm just going to go over what we learned. Angles on the same side of the transversal in the same position are called corresponding angles. When angles on opposite sides of the transversal and between the parallel lines interior, they're called alternate interior angles. When angles are on opposite sides of the transversal and outside the parallel lines, they're called alternate exterior angles. When parallel lines are cut by a transversal, corresponding angles, alternate exterior angles, and alternate interior angles are all congruent. So again, it's a lot of vocabulary, but it's kind of logical if you remember your rigid motions. Thanks. Have a great day. I'll see you tomorrow.